This is the physical scale of the Earth. Thousands of miles of rock, water, and ice. For most of human history, these landscapes were limits. If you wanted to share an idea with someone on the other side of these mountains, that information could only move as fast as a physical body could carry it. A running courier, a galloping horse, or a wooden ship. In the early 19th century, a message sent from London to Bombay took months to arrive. By the time it was read, the news was already old. These hard physical delays meant that human cultures and economies developed in relative isolation, bound by the edges of their own maps. Geography was destiny. The distance between 2 points was an unyielding barrier that humans simply could not overcome. This page from a computer science textbook poses a direct question. What is Internet? Translated from the original Punjabi, the text offers a specific definition. The Internet is what has gathered the whole world together and placed it in our fist. It describes this connectivity as a tool provided to humanity. When contrasted with those impassable mountains and silent oceans, the claim suggests that the planet has essentially been resized. But how is that actually possible? How do you take a massive, rocky planet and mechanically shrink it until it fits in the palm of a hand? We often talk about the Internet using metaphors like the cloud, as if it's an invisible, weightless force. But the Internet is a purely physical machine. It began in rooms filled with metal cabinets. These early mainframe networks relied on thousands of feet of physical cables to let machines communicate. To create a global network, engineers had to extend those physical wires across entire continents and thousands of miles of deep ocean. Today, hundreds of heavily armored communications cables lie directly on the seabed. They snake through trenches and across abyssal plains, bypassing the geography above by running directly underneath it. These lines are the actual arteries of the global Internet. Beneath the heavy armor of those sea cables lies a core of glass threads, no thicker than a human hair. This is fiber optics. These filaments translate human data, emails, banking records, videos, into pulses of light. Every second, an immense volume of data travels through these specific strands, moving as light rather than electricity. A signal can leave Tokyo, dive under the Pacific, and reach London in less than 200 milliseconds. That is faster than the time it takes for a human to blink. We bridge the distance between us by converting information into light, moving it at the fastest speed physically possible. Those light pulses eventually hit a data center, travel through local lines, and finally convert into the invisible wireless signals that surround you. The journey ends here, in the palm of your hand. This simple device is the physical manifestation of that textbook's claim. It is the endpoint of a global infrastructure of glass and steel. Geographic isolation has become an illusion. Through this machine, every individual is now physically tethered to the rest of the human race.